Welcome back. We're going to look at section 1.3, which is over writing expressions. And remember that when we talk about section 1.3 and this idea of an expression, we're talking about using a verbal model to an expression that describes a problem using words as labels and using math symbols to relate words. We're going to be talking about the idea of a rate, a fraction that compares to quantities measured in different units. And we're going to be talking about unit rates. A rate per one given unit. Some things that are common, right? Miles per hour, minutes per dollar, dollars per minute. So taking a look at those pieces is where we're headed. Now we have some verbal things, some verbal tool bag items. We have some words that mean addition, some words that mean subtraction, some words that multiplication, some words with division. I think that all of these are important words, but I want to point out to you a couple of things. The idea of more than, when we see that word sum of, so more than is just telling us to add. But when we see this word sum, we should be thinking that's a quantity. We may or may not actually need the parentheses, but we should always be thinking of it as a quantity with an addition sign in the middle. Same thing happens here with difference. Difference. When we read that word difference, we should be thinking subtraction, and we will most likely need a set of parentheses. I want to call your attention to, and we're going to focus here in a little bit on this phrase less than compared to the phrase less. Oh, I'm sorry. No. Less than and less mean the exact same thing, but we're going to be looking at something similar with that word than, and how to use them and how they are different slightly because of that word than. We're going to talk about multiplication, times multiplied by the word of. Again, the key word product, when we use that word product, we're going to be thinking we may need parentheses. It's pretty likely that if I read the word product, I'm going to need parentheses. And then last but not least are your division words. Divides, divided by, divided into, fraction, ratio, the quotient of. So we're going to use parentheses. When you read it, the quotient of this over that, this compared to that, the quotient of x and y. The first goes on the numerator and the second goes in the denominator. Some extras here that are pretty obvious. The quantity tells you what to group when translating verbal phrases. The square of tells you to square it. The words unnumber tell you to write a variable because the actual number is unknown. So let's go ahead and do a few practice problems together. And we're going to kind of use I work through some, then give you a chance to practice. So we'll be doing some pausing in between here in this section. Let's go ahead and take a peek at question number 1. And in question number 1, hello lovely marker, where are you? There you are. I want to point out that the first thing I do when I do these problems is I take out the words and I put the numbers and the symbols in their place. So simply replacing things tells me to take 5 times y. Well, we know that we would write 5 times y smushed together because we don't need a multiplication sign in between. So 5y is the translation into an expression. Try it again. 12 less than. 12 less than, well, that means I should really subtract 12, right? 12 less than something. So take that something, which in this case is a mystery number, x, and subtract 12 from it. So take x and subtract 12 from it. So I've given you 2. Pause it. Try the top 2. So try numbers 3 and 4. I hope you're pausing it. Pause, 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 please. So hopefully when you looked at that problem, 3 and 4, you ended up with work that looks something similar to this, an addition problem and a multiplication problem. Now let's work through problem number 5. Half, again, cross it out, replace it with of a number. Of, we know, means multiply, and a number, b. Half times b, so we translate to half times b. How about number 6? 2 times, we'll use the number 2 and a multiplication symbol. The sum, well, that's definitely an addition and most likely needs parentheses. Look, don't even have to translate 5, you can just put it in there. And a number a. So take 2 times a quantity that has an addition of 5 and a. Put it in pretty mathematics. 2 times a quantity, 5 plus a. Boy, are you getting used to this yet? Pause it and check it out. See what you can do on the next one. Pause it and mean it. So hopefully you've done 7 and 8. Number 8 is a secret problem. We're going to do that one in class. I'm going to ask you to record your answer as part of your whisk. So number 8, make sure that you do that problem as your secret problem. Let's work through number 9. And in number 9, again, going through my whole process here. Let's change our color again, just so that it all stands out. The product, oh, there's more multiplication. Multiply 5, and the quantity, oh, those are definitely parentheses. 12 plus a number. Well, hopefully that's not too tricky. Multiply 5 times 12 plus a number. Oh, they didn't even give me a variable, so I get to pick my own. I'm going to pick x. So that this is a multiplication. 5 times this quantity. So proper mathematics says that we would write it like this. 12 plus x. Last, but certainly not least, give number 10 a try. Looks like I have some cleaning up to do. Hopefully you paused it before I put that answer up there. And if not, no problem. With or without parentheses. Let's go to the next one. Number 17. We're doing a food drive. You and 3 friends are collecting canned food for a food drive. You each collect the same number of cans. Write an expression for the total number of cans collected. Remember, this is you and 3 friends. You're all collecting the same number. Write an expression for the total number of cans collected. When we're asked to do this, sometimes it's going to be easier to write a verbal model. And perhaps your verbal model doesn't match the one that they put here from your book. So they're taking the amount of cans times the number of people. The amount of cans is what we don't know. We don't know how many they've collected each. So we'll call that x. There are, in fact, 4 people in this problem. So my expression that represents the total is going to simply be 4 times x. In example 2, suppose that the total number of cans collected are distributed equally to 2 food banks. Write an expression that represents the number of cans each food bank receives. So if we used a verbal model, we would say the number of cans divided by the number of food banks. 4x divided by 2. 4 over 2 is a fraction. We know how to simplify, so 2x. Here's another place for you to stop in the name of math. Before you go any further, think it over. Give them a try. Hopefully you didn't have too many troubles with that. So the next piece in example 3 is over unit rate. The idea, remember, right from our vocabulary, is the idea of unit rate is to find out how much it costs for one of something. So in this problem, we're looking at 3 gallons that cost $9.15, and we're asked to find the unit rate. Remember, we're looking for the cost of 1. So we take $9.15 and we divide it by 3 gallons, dollars per gallon. When we do that division, $9.15 divided by 3, we get $3.05. You'll notice that over here on the side, I went ahead and I did the long division. The reason that I've given you this long division is to remind you that on Friday when we take that placement test, it will not have any calculators being allowed. So just a reminder there. So, with unit rate, it's acceptable to use common measures, and decimals are also okay with a unit rate. So, normally we would say that 3.05 cannot be part of a fraction. But because we're talking about rates, it's perfectly acceptable. So go ahead and pause, try these last few. Hopefully you went ahead and paused. And here are some answers. I went ahead and when I was reading it, I put the common measure. Usually they just go in order, but sometimes they don't. Number 1, we could do how many hours per mile, but that's going to give us a really different answer and something that doesn't make sense to us. So usually when we see miles, we do miles per hour. Dollars per foot, cups per person, so that we end up with these possible answers. Alright, it's about time for you to go ahead and whisk. Enjoy!